All right, Integrated Math 3. This is lesson 2.02 on factoring polynomials. The due date originally was March the 3rd. I'm changing that to Monday, March the 8th, since I'm just getting this answers video up. So I'll go ahead and write that here. All right, and that'll be next week as I'm videoing this right now. Okay, so factoring is basically breaking a polynomial apart into pieces until you can't break it apart any further, and there's just certain rules for doing that. Since there's enough problems here, I'm not going to do a PowerPoint instruction video on this. Just go ahead and watch the examples and you'll pick up how to do it, and then I'll leave a few of them for you to do on your own. Okay, so this is both the instruction and the answers video. Okay, so factoring means that you pull out anything that the terms have in common. So how do you know what the terms have in common? Well, one thing you do is you factor everything into prime factors. That means a factor that can't be broken up any further. So you take this and you break it into prime factors. So start with the 8. And if you don't know how to do that, you just start with an 8 and you draw a tree, a factoring tree. And it has 2 branches. So what are 2 numbers that multiply to 8 other than 1 and 8 themselves? So the answer here, there's only 2 other numbers that do. It's 2 and 4. Okay, so the question is, can you break either one of these into any further? You can't break 2 down any further because only 1 and 2 divide into 2. But 4, 2 and 2 divide into that, so you can break that down into 2 and 2. And 2's are all prime numbers. Nothing divides into them other than 1 and themselves. So this is your factoring of 8. It's 2 times 2 times 2. So let's write that down here. It's 2 times 2 times 2 equals 8. You can do the same thing with 10. And other than 1 and 10, the only 2 numbers are 2 and 5. Those are both prime factors. Those are both prime numbers, rather. Yeah, they're both prime factors. So that's what breaks down there. Okay, what about x squared? Well, what does x squared equal? X squared equals x times x. Okay, and what about x? Well, that's just x. So what you do is you have 8x squared. So that's equal to, we're going to write that down here. That's equal to 2 times 2 times 2, and the x squared we just said is equal to x times x. So what we're doing is you're writing everything in terms of its prime factors. So that is equal to 8x squared, that right there. Now what we do is we take the other term and we place it down below, and we try to match up any numbers and any variables x that we can. So for 10, it was 5 times 2, 2 times 5. I'm going to write it as 5 times 2. And then there's that x all by itself, so I'm going to put that x right here. Now what you do is you take these two, this is 10x prime factored out, and this is 8x squared prime factored out. You circle anything that they have in common. Well, what they have in common is the x right here, and the 2 right here. They don't have anything else in common. This 2 doesn't have a 2 to match up with. This 5 doesn't have a 5 up here to match up with. This x is all by itself. It doesn't have anything. So what you can factor out of this is 2x. And what you have left in the parentheses is what you didn't circle. So for the 8x squared, let's write that very clearly, which is which, so we don't get them confused. That's 8x squared, and this one down here, this one right here, is 10x. So we were able to factor out a 2 and an x, not 2 times 2 times x times x, just 2 times x right there, because they have that in common. Now what you have left behind in the parentheses is, for the 8x squared term, is whatever was not circled. So that's 2 times 2 times x. That equals 4x. And then for the 10x term, the only thing that you didn't circle was the 5, so you add a 5 there. You add it because there's a plus sign right there. Okay, and that is our answer. And the way you check your answer, this is called factoring. We broke this apart. Now you re-expand it again, and I'm going to do that as a way to check my work. You don't have to do this on all the problems, but it's a way you can check your work if you weren't given answers. So 2 times 4 is 8, and x times x is x squared. And 2 times 5 is 10. And then the x times nothing right there is just x. There's no other x there. So that's what you get when you expand this back, and that's our original equation. So this is the answer. This is just a way to check the answer. Okay, so go ahead and try doing number 2 on your own. Okay, and you can pause and then I'll restart. Okay, so I'm going to go ahead and do this. I'm going to start with 12. I'm going to factor that out. There's 2 different sets of numbers, 4 times 3 or 2 times 6 that will multiply to 12. I'll go ahead and take 2 times 6. 2 is a prime number. I can break the 6 into 2 times 3. Those are all prime numbers. These right here, it's everything at the bottom of the branches. So it's 2 times 2 times 3 equals 12. 16, do the same thing. 16, you can break that into 4 times 4. 4 you can break into 2 times 2. This 4 you can also break into 2 times 2. So what we have is 2 times 2 times 2 times 2. That equals 16. And then all you have here is this y, so there's nothing really to do with the y's. Okay, so let's come up here and let's write the 12y term. And that equals this. This is 12. So that's going to be 2 times 2 times 3 times that y right there. And the 16 term, by the way, we'll ignore the negative sign for now. Just deal with the numbers. And 16 we just said is 2 times 2 times 2 times 2. Okay, so what do these have in common? They have this 2 and this 2 in common. They don't have any more 2's in common. There's no more 2's on the top. There was no 3's on the bottom. There's no y's on the bottom. So they have 2 times 2 in common. So 2 times 2 is going to come out of the parentheses. And it's just going to be 2 times 2 is, let's do that right, it's going to equal 4. Then what you leave inside of the parentheses is what you didn't circle here. 3 times y. So it's going to be 3y. And then down here you didn't circle 2 times 2 is 4. So you're going to have another 4 there. And then they're going to be separated by this minus sign. So that's your final answer. Okay, so that's your final answer. So again, let's distribute to check our work. 4 times 3 is 12, and then you have the y there. Minus 4 times 4 is 16, and you get 12y minus 16. That's what you started with. So that's how you know that you did the problem correctly. Okay, let's do another. Again, what I would say is set minus signs aside during the problem, but don't forget that they're there. Well, I'm going to tell you on this one, it's a little bit of a different situation, but let's go ahead and do that. Okay, so 15. So it's going to be 15. You're going to break that into 3 times 5. 3 times 5, those are both prime numbers, so you're done with 15. 45 is going to be, and again, you might have to get out a calculator and try what are 2 numbers that multiply to 45 if you don't know your times tables that well. That's going to be 3 times 15. And then the 15, just like this one, is going to break into 3 times 5. So for 15, it's 3 times 5. And for 45, it's going to be 3 times 3 times 5. The numbers that are down at the bottom there. Okay, there that is. Now, you've got d to the 5th. What does that equal? That equals d times d times d times d times d. That's what d to the 5th means. And d to the 3rd is d times d times d. Okay? So, let's go ahead and let's write this down. So, minus 15 d to the 5th and 45 d to the 3rd. So 15 we said is this. So it's 3 times 5. And then we have those 5 d's, d times d times d times d times d, so I'm going to put that here. Okay, so we've broken that one totally to pieces. Again, I'm set aside the minus sign for right now. Okay, the 45. Okay, we have that's 3 times 3 times 5. And then it's d to the third, so that's going to be times d times d times d. Okay, so we've broken everything apart. What do they have in common? They have these 3's. They have the 5. They have these 2 d's, these 2 d's, and these 2 d's. These 2 d's don't match up with anything. This 3 here doesn't match up with anything. So what is that? It's 3 times 5 is 15. And d times d times d is d to the third. And now I'm going to go ahead and I'm going to stick this minus sign back on there right now, like that. So they have 15d to the third in common. And what stays inside the parentheses is whatever is not circled. So that's d times d is d squared. And then this 3. And that's a positive 3, so it's plus 3. And this is your answer. Let's verify it. 15d to the third times d squared is going to be minus 15d to the fifth. And then, oh, okay, so here's where I made a little goof here. Then this is why you check your work. Negative 15d squared, d to the third times 3 is going to be negative 45d to the third. But that doesn't match. That's a plus sign. So what do we have to do? We have to make a change here. So what we're going to do is we're going to turn that plus sign into a minus sign. Can you do that? Sure. You do whatever you have to do to make this multiply out to that. So I'm going to make that a minus sign. So that means negative 15 times negative 3 is positive 45. Everything else checks out though. So now I do have exactly the same thing I started with. I had to make that change. It's one of the reasons why you want to do this redistribution, especially with negative signs, to be sure you've got your negative signs straightened out, okay? All right, so that is the factored form of this. That's the answer to this. Okay, let's keep going. This one just has c's in it. All right, so let's just write this out up above, or down below rather. Here is c to the third is going to be c times c times c. That's what c to the third means. C squared is going to be c times c. And c is going to just be a c right there. So what do they have in common? Well, the only thing that all 3 of them have in common are these c's right there. They all have to have it in common, okay? They don't all have 3. This doesn't, this is only 2 and this is only 1. All right, so what's going to come out of the parentheses is a c. And then what this one's going to have up here is c squared. C times c is c squared. What this one is going to have is a c, so it's plus c. And this one doesn't have anything that's not circled. So what's that last term going to be? Sometimes students get fooled and they say, oh, it's got to be 0. There's nothing there. It's 0. No, it's going to be a negative 1. Why? Because c times negative 1 gives you negative c. If you had a 0 there, it would be c times 0, and there would be no term there. So c times negative 1 is negative c. So again, let's distribute to check. C times c squared is c to the third. C times c is c squared. And c times negative 1 is negative c. And that is the same thing as that. So this is your answer right here. That's your answer. Okay, that's the factored form. All right, let's keep going. All right, so this one, we did this one in class. Let's go ahead and do it again. So if you can't see that 6 divides evenly in all these, if you can see that, you're way ahead and you can move quickly through this problem. But if you can't see that, you got a prime factor 6. It's going to give you 2 times 3. Prime numbers. 30 Again, ignore the minus sign right now. And that's going to be 5 times 6. And then 6 can factor into 2 times 3. So this is the prime factored form of 30. And then 42. And in class we said 2 times 21. So let's say 6 times 7. That also multiplies to 42. So this can break into 2 times 3. So there, that's prime factor. So 6 is 2 times 3. 30 is 5 times 2 times 3. And 42 is 7 times 2 times 3. Okay. They don't all have an n in common, so n will not factor out. They'd all have to have at least one n to factor an n out, but they don't. This one doesn't have an n, so you can't factor that out. So the only thing we're looking at is the 2 times 3. They all have a 2 times 3 in common. So let's go ahead, and it's 2 times 3 times n times n. That's this one right here. So this is the 6n squared. Let's go ahead and label that. The 30n is going to be this. 5 times 2 times 3, and then there's the n there times n. And then finally 42 is going to be 7 times 2 times 3, and there's no n there, so you just have to leave that. So the only thing that all three of these have in common, they have to all three have something in common to factor it out, is the 2 and the 3. And 2 times 3 is 6. So you might have seen it right off the bat that 6 does go evenly in all those. You would have, as I said, you would have been way ahead of the game if you had done that, okay? But if you didn't, this is the way you do it. So I'm going to go ahead and write 6. That's the only thing that comes out of the parenthesis. Okay, and then for this term up here, you have n times n, so that's going to be n squared. Okay, now be careful, you have a negative sign here and a positive 6. So the next term is going to have to be negative because we need this to be negative. And what do you have? You have a 5 and an n that were not circled, so 5n. And finally, down here you have just the 7, so it's plus 7. So 6 times n squared, we're going to check our work, is 6n squared. 6 times negative 5 is negative 30n. And 6 times 7 is 42. Okay, and that's the equation that you started off with, so that's the answer. Now the question is, can you factor this? And we did this in class and showed that we couldn't. I'm not going to do it now because we're going to do enough of these coming up here that these do factor where it's a quadratic. That's something that the largest power is a square. We're going to do enough of these that do factor that I'm not going to bother with this now. I'm just going to tell you this doesn't factor any further. So this is the complete answer. This is just checking our work right here. Okay? All right. Okay, this next one has to do with a concept called factoring by grouping. And it deals with a couple of things. One is that the highest order, the highest degree, is a 3. The other thing you're going to notice is what you're going to do is you're going to group the first 2 terms in parentheses and these last 2 terms in parentheses. And you're going to notice a relationship. That go ahead and write the coefficient in front of x to the third as being 1, just to emphasize that there is a number there, it's a 1. Notice that this number is twice this number. And this number, 8, is twice this number. Now it doesn't have to always be twice the value, but as long as the ratio of this number, the relation of this number to this number, is the same as the relation of this number to this number, in other words 2 to 1, this is a 2 to 1 ratio, and 8 to 4 is a 2 to 1 ratio. You have twice as many here as you have here. As long as they have the same ratio, you can use this method. Again, it has to be a cubic function, x to the third, and that relationship has to exist. All right, so what you do then is we're going to just take this by itself and we're going to come over here and we're going to write that here. We've got plenty of space here. X to the third plus 2x squared. Okay, and what x to the third is it's x times x times x. And what 2x squared is it's 2 times x times x. Okay, so we're going to factor just this right now. So what do they have in common? They have this x, and that's it. This x doesn't match up with another x, and the 2 doesn't match up with a 2. So you're going to bring x times x out. It's x squared. And then it's going to be another x that stays in, plus this 2 stays in. So that's how this would look factored. Now we're going to do the same for this one. Okay, and what's this going to be? Well, we can look at this. We don't have to draw a tree. I think you can all see that's going to be 2 times 2. So it's going to be 2 times 2 times the x here. And what about this? We already did 8 earlier. It's going to be 2 times 2 times 2. So this is the 4x. I should have written this for both of these. This is the x to the third. This was the 2x squared. This is the 4x, and this is the 8. So what do these have in common? They have a 2 and a 2. That's 2 times 2 is 4. And then in parentheses you have the x plus 2. Goes right there. Okay, so x squared times x is x to the third, and x squared times 2 is 2x squared, so this one checks out. 4 times x is 4x, and 4 times 2 is 8, so this one checks out. So I'm going to write these two, and then notice in between them is a plus sign. Okay, so remember what I did is I took this, pulled it over here by itself, took this, pulled it over here by itself, but over here they're really connected by a plus sign. So I'm going to write this, x squared plus this. Okay, so that is this factored. But we're not done, because you may notice something. Now you have two terms which you can stick into square brackets here. And square brackets are no different than parentheses. I just don't like to have two sets of parentheses because it's confusing. So just treat the square brackets as though they're a second set of parentheses. So treat this as a term and treat this as a term. And what do they both have in common? They both have x plus 2 in common, there and there. So that means we can factor x plus 2 outside of these square brackets, okay, because it has them both in common. So I'm going to do that, x plus 2. Then I draw the square brackets. So I pulled this out, so the only thing I have left behind is this term right here, x squared, plus over here I pulled this out, the x plus 2, I pulled it out. So the only thing I have left there is the 4. Okay, and that's your answer. You might want to rewrite it with the rounded brackets, but you don't have to as far as I'm concerned. Okay, and that's your final answer. Now you might ask yourself, does this factor? And the answer is no. X squared plus 4 does not factor. You might remember from Integrated Math 2 that x squared minus 4 would have factored. It would have been x plus 2. It's called the difference of two perfect squares, because x squared is a perfect square and 4 is a perfect square. So it would have been x plus 2 times x minus 2. If that had been a minus sign, that would have factored. That would have factored, but it's not. It's a plus sign. There's no way to factor that, okay? All right, so this is the final answer for this problem. Okay, let's look at number 7. I'm going to leave this for you to do. I'll just get you started. It's the same type of problem as up here. I'm going to group these. Notice it does have a cubic. The third power is the highest exponent. And now see what the ratio is. Forget the minus sign for a second. It's 6 to 2. That's a 3 to 1 ratio. This number is 3 times greater than this number. And this is also a 3 to 1 ratio. This number is 3 times greater than this number. So they have the same ratio, 3 times this, and this is 3 times this. Okay, there you go. You have this one to factor out. You have this one to factor out. So go ahead and do that. You do it exactly the same way. The only thing that you got to watch out for are those minus signs, okay? Just don't let those trip you up at the end, okay? So I'm going to call this a U problem. It means you do this one. And I'm going to check your work on this one. So these are the ones I count more when you in terms of your score, okay? Is the ones that I leave for you to do. Do it exactly like this one up here. Okay? All right, I'm going to move on. If you want me to do that one with you, come to tutoring. And I'll do any problem with you. Okay, it looks like a similar type of problem here, number 8. Let's group them. It is an x to the third power. Again, this number is twice this number. 6 is twice 3, and 4 is twice 2. So they're both 2 to 1 ratios. The second number is twice the first number. So that means we can use this method. Okay, so I'm going to do what I did before. 3x to the third plus 6x squared. Okay, so I'm going to take the 3x to the third. You can't factor 3 any further, so it's going to be 3 times x to the third is x times x times x. And then the 6x squared. Okay, and you can factor that into 2 times 3. We've already done that, so I won't show you that again. And then x squared is x times x. Okay, and what do these have in common? They have the 3, they have an x there, and they have an x there. So that's 3 times x is 3x squared. So that comes out of the parenthesis. And then for this term, the only thing not circled is the x there, so that's an x. And for this one, it's a 2, and there is a plus sign between them, so you put a plus sign here. Okay, so this is the factored form of that. Okay, see if you can do this one by yourself before I do it. Okay, so it's 2x. Again, you can always stop the video. Minus 4. So 2x is simply 2 times x. We're going to ignore the negative sign for a second. The 4 is going to be the 2 times 2. So the thing they have in common is this 2. So I'm going to write a 2, parenthesis, and then this one is an x. Now be careful, this is a minus sign, so I'm going to put a minus 2 for that. Okay? So there you go. You factored this over here, and you factored this over here. Now we're going to put it back together again, remembering there's a negative sign between them. So you got to be careful on that. There's another negative sign in there. So it's this, 3x squared. I'm going to give myself a little more space here. (3x squared) times x plus 2. Okay. And then it's minus 2 times x minus 2. Okay, and I'm going to put my big square brackets like that. Okay, now I have a little problem. Remember we said on this one, now what we're supposed to do next is factor out this and this. But these two are not the same. One is x plus 2, one is x minus 2. Alright, so what I should have done here is I should have taken this minus sign and multiplied it through to this and to this. And what that's going to do, it's going to change the sign on this to make this minus 2x. So negative 2x, and then it's going to make this a negative negative, which is a positive, so it's going to make this a plus 4. So that's going to make this a minus 2 and this a plus 2 when I get down here. Okay, I know that can be a little tricky, but that's what it turns it into. Okay, so this becomes a plus 2. So let me say that again. If before I had come over here, I had distributed this through. So what I could have done is what we did in some of the earlier problems. I could have turned this into a plus sign times negative 2x plus 4. That's what I could have done here. Change this to a plus sign and then multiply this negative through to make this negative 2x and negative positive 4. So now I bring the negative 2x over here, and what I can do is just call that a negative 2 right there, and excuse me, not call it, just put the negative sign, just put the 2 down there, put the negative sign in front of it, and then this is x plus 2. Okay, so anyway, you end up with that. Just remember, when you do these two have to be exactly the same. It can't be x plus 2, x minus 2. Just can't do that. So now we're ready to factor this out. So it's going to be x plus 2. And then in my square brackets, I have 3x squared minus 2. Again, if you want to write those as curved parentheses again, just to get them back to normal, you can, but it doesn't matter. You can just leave them like that, okay? And that's that. That's the answer to this. All right, let's keep going. Okay, now we're going to get into factoring a quadratic. I told you earlier we were going to skip one that kind of looked like this because it didn't factor, and we were going to get to some that do, so let's go ahead and let's go ahead and do this. All right, so how do you do these? Well, there's no coefficient there, but if there were, it would be a 1. So what you do is you always on these, you multiply this times this, and that's called the grand product. So I'll put a time sign. It's not an x, it's a time sign. So it's 1 times 24. As long as the coefficient here is 1, it's always going to be whatever that number is, okay? So that number is going to be minus 24. So you need to find two numbers that multiply to that grand product. And this is the way I do it. You may have learned it a different way, and it's fine if you use the other way you learned it. Okay, it's got to add to this central number here. So it's got to add to 5. Okay, so be sure you understand that it has to multiply. As long as this coefficient is 1, it's got to multiply to that number and add to that number. If this number was not a 1, then you really do have to multiply whatever it is. Let's say it was a 2, then it would have to be 2 times negative 24 would be negative 48 that this would have to be multiplied to. But it's not. It's a 24, negative 24, so there it is. Okay, so if two numbers multiply to a negative number, it means one of them has to be positive and one of them has to be negative. That's just, two positive numbers give you a positive number, two negative numbers give you a positive number rather. One positive, one negative gives you a negative number. Now if they add to a positive number, it means the bigger of those two numbers has to be the positive number in order to get it into the positive zone there. So what I'm going to do is simply start with a small negative number and the larger positive number to get negative 24. What would that be? That would be negative 1 times positive 24. So that times that does equal negative 24. Now I'm going to add them. Negative 1 plus 24, that equals 23, positive 23. Well, that's not what we're looking for. We're looking for 5. So now we have to go to the next number. Let's go to negative 2. So negative 2 times positive 12 equals negative 24. Negative 2 plus 12 equals 10. Well, 10 does not equal 5, so we got to keep going. How about negative 3? Negative 3 times 8 equals negative 24, and negative 3 plus 8, and do these on your calculator if you need to, because the negative numbers can mess you up, and that equals positive 5. So that's the one. So these are the two numbers we're looking for, negative 3 and 8. So all you simply do is create two binomials, x minus 3, that minus 3 right there, and x plus 8, that 8 right there. Okay. What this does for you that the square method or the diamond method doesn't do is it helps you just systematically work through each pair of numbers that can multiply to this, and then you check to see if they add up to what they need to add up to. So you just start with the smallest negative number. It's actually the most positive number, but it's, in other words, it's a -1, then -2, then -3, then if we had to, -4. -5 wouldn't have gone into 24, but -6 would have. So you just work your way down the list until you find the pair of numbers that works, okay? Now the way you check your work is you FOIL this. So FOIL is first, so it's x times x is x squared. Outer is x times 8, so that's 8x. Inner is -3 times x. Inner means these two that are on the inside here, times x. And finally, last is -3 times 8 is -24. The middle two terms will always combine because they're both x terms, so it's 8 minus 3 is 5. So it's x squared plus 8 minus 3 is 5, 5x minus 24. And this is the equation that we started with. So that's the way you can always check your own work. Even if I didn't give you an answer key, you could check your work on these to see that you're doing the problem correctly, okay? All right, so that's factoring a quadratic. That's something you did in integrated math too. Okay, let's do another one. Go ahead and do this one. Again, just pause the video, see if you can do it by yourself, okay? It makes the assignment more interesting than just copying. So give it a shot, see if you can do it by yourself. Okay, so let's go. So I got to multiply to equal 1 times 20, but again, when this is 1, it's just going to be this number right here. So it's got to multiply to positive 20, and it's got to add up to -9. Okay, it has to add to that number in the middle and has to multiply to that. If two numbers multiply to a positive number, they both have to either be positive or they both have to be negative. Since these two numbers are going to add to a negative number, they can't possibly both be positive. You can't add two positive numbers together and get a negative number. So they're both going to have to be negative. Okay? So I'm dealing with two negative numbers. So I'm going to go ahead and just find combinations that multiply to 20. I'm going to start with -1 times -20. So that does equal positive 20. -1 plus -20 is going to equal -21. That does not equal -9, so that's not the 2. Let's go to the next number, -2. -2 times -10. That does multiply to be positive 20. -2 plus -10 equals -12. That does not equal -9. So -3 does not go evenly into 20. 3 does not go evenly into 20, so skip that. Let's go to -4 times -5. And that's -4 plus -5. And that's going to equal -4 plus -5 is going to be -9, and that is the number we're looking for. So these are the two numbers we're really looking for there, -4 and -5. Okay, so it's simply going to be m minus 4 times m minus 5. Okay, -4, -5 right there. And that's your answer. Let's check it. First, m times m is m squared. Outer, m times -5 is -5m. Inner, -4 times m is -4m. And last is -4 times -5 is plus 20. These two combine. So -5 times -4 is -9. And then you have the plus 20 down there at the end, and the m squared at the beginning. And this is the same as the original equation there. So this is the answer to the problem. So this is called factoring, and then what we're doing to check our work here, to get back to here, that's called expanding. Factoring, expanding. But the problem is asking us to factor. We're just expanding to check our work. Okay, let's keep going. Okay, We've got another factoring of a quadratic. This one adds a complication that this number is not a 1. So the first step is to find the grand product, and that's going to be this number times this number. You always do that even on the previous two, but it always 1 times whatever that number is going to be that number. But that's not going to be the case this time. It's 3 times 4, so the grand product is 12. So we need to find two numbers that multiply to 12. And they're going to have to add to -8. That part doesn't change. Okay? All right, so if they multiply to a positive number, they either both have to be positive or they both have to be negative. Since they add to a negative number, that means they both have to be negative. So I'm going to just start with this, the lowest negative number is -1 times -12. That gives you positive 12. -1 plus -12 equals -13. That's not what we're looking for. We're looking for -8. So let's go to -2. -2 times -6. That does multiply to positive 12. -2 plus -6 equals -8. And that's what we're looking for. So the two numbers we're really looking for are -2 and -6. Okay? Now, there's an added step. You can't just say x minus 2, x minus 6 like we did before. We have to deal with this. So let me show you the little shortcut way to do this. Explaining the math behind why this works would take about 1 or 2 pages of writing, and you don't need to understand it. So I'm just going to show you how to do it, and you just have to remember the system. You take the 3x there, not 3x squared. So take 3x, whatever this first coefficient and variable is, not, and let me emphasize this, not 3x squared, just 3x. And you place it over each of these two numbers that you came up with here. So it's going to be 3x over -2, and this one's -6. It's going to be 3x over -6. Okay? So now you have two ratios, and now you reduce them. So 3 over 2 doesn't reduce. You can't reduce that any further. 3 over -6 reduces. 3 goes into 3 once, it goes into 6 twice. So I can reduce this one down to x over -2. Be sure you're comfortable with that. 3 goes into 3 one time, and 3 goes into 6 2 times. So it's 1x there minus 2. X minus 2. Be sure you're comfortable with how I got that. Just reducing a fraction. Okay, now all you do is you turn these into binomials. There's no normal rule of math that says you can take a ratio and turn it into a binomial. But we can do it here because of all that math that I told you that's in between that I'm not going to explain to you. Actually, it ends up working. So watch what I do. I simply make this 3x minus 2, that one, and this one I make x minus 2. And that's your answer. Believe it or not, that's your answer. Let's prove it. Let's FOIL it. 3x times x is 3x squared. 3x times -2 is -6x. -2 times x is -2x. And -2 times -2 is positive 4. You can group the 2 in the middle. They always group together. So -6x minus 2x equals -8x. And then you have the 4 down here, and you have the 3x squared here. And that checks out with what your original equation was. So again, this is your answer. That's your answer, but I'm just checking my work. So 3x squared minus 8x is 4 is what we started with. So this is the factored form of that. So let me say that again. You start off doing it the same way we did before, except you have to not just use this number to multiply to, you have to use the grand product of 4 times 3 is 12. Then they still have to add to -8. That doesn't change from the way we did the earlier ones. We ended up just trying out different combinations until we found out that -2 times -6 is 12, and -2 plus -6 is -8. So -2 and -6 were our numbers. Now on the previous example, we would have just said x minus 2 times x minus 6 and we'd be done with the problem, but not here. You take the 3x, the first coefficient, and that variable x. You do not use the squared, so that's why I wrote this. And you place 3x over this number, -2, and you place 3x over this number, -6. So 3x over -2, 3x over -6. 3x over -2 doesn't reduce, so you can just turn that right away into a binomial, 3x minus 2. 3 over 6 does reduce. 3 goes into 3 one time, it goes into 6 two times. So it's basically 1x, which is x, minus 2. So that becomes x minus 2, and that's your answer. Okay? It's about, a few extra steps, 2 extra steps that you have to do on this one, but it's the same every time, so don't let it scare you. Okay? Alright, I'm going to do this one, and then I'm going to make number 13 a U problem. It's the same type. Let's do this one together first. Okay, grand product. First step, grand product. Multiply 2 times 6 is 12. So we need to find two numbers that multiply to 12. And they add to 7. There you go. Add to 7, multiply 12. Okay, everything's here is positive, so we know they're going to be positive numbers. So let's just start with the lowest possible number is 1. 1 times 12 equals 12. And 1 plus 12 equals 13. That's not what we're looking for. We're trying to get 7. Let's try 2. 2 times 6 equals 12, and 2 plus 6 equals 8. That's not what we're looking for. Let's try 3. 3 times 4 equals 12, and 3 plus 4 equals 7. That's what we're looking for. Means the two numbers we're looking for are 3 and 4. Okay. So think about what you do next. You take the 2x and you make a ratio. 2x over 3, 2x over 4. Okay, 2x over 3. 2 over 3 doesn't reduce. So you can go ahead right away if you want to turn that into a binomial. 2x plus 3. 2 over 4 reduces. It becomes 2 cancels. 2 goes into 2 one time, goes into 4 two times. So it's 1x, which is x, over 2. And it's a positive 2. So that means the second term is going to be x plus 2. Again, let's quickly FOIL it out and check our work. 2x times x is 2x squared. Plus 2x times 2, that's the outer, is 4x. Plus 3x. Plus 6. These two, the 2 in the middle, always pair up. 4 plus 3 is 7x. And then the 6 is the same at the end, and the 2x squared at the beginning is the same. And you have the same thing that you started with up here. Okay, so you checked your work. Okay, this one's exactly the same as the previous two. Doesn't have any negative signs to trick you. So go ahead and do it exactly the way that the previous two were done, okay? And check your own work by FOILing it back out and seeing if you end up with the original equation, okay? So I'm going to leave that one for you. Let's go ahead and move on. Okay. Here's another one, same thing. So I'm going to do it kind of quick here, just to show you homework doesn't have to take you a long time. So it's 6 times 5, so you're going to have a multiply to 30. That's 6 times 5. And you're going to have to add to negative 17. Okay. Positive number, they both have to be positive or they both have to be negative to multiply to a positive number. Since they add to a negative number, that means they both have to be negative. So I'm going to start with a negative 1 times a negative 30. That equals positive 30. Negative 1 plus negative 30 equals negative 31. That's not what we're looking for. We're looking for negative 17. Negative 2 times negative 15. That equals positive 30. Negative 2 plus negative 15 equals negative 17. That's what we wanted. So the two numbers we're looking for are negative 2 and negative 15. Now we take the 6n and make a ratio, 6n over negative 2, and then 6n over negative 15. Okay. So 6 and 2 goes into 6 evenly. It goes in 3 times. So you can cancel that. 2 goes into 2 once, goes into 6 3 times. So now I've reduced this one. So it's 3n minus 1. Be sure you know how to read that after you've done the cancellation. 3n minus 1. 3n minus 1. Now, 3 goes into both 6 and 15. It goes into 6 twice, and it goes into 15 5 times. 3 goes into 6 twice, and into 15 3 times. So I have 2n minus 5. Again, be sure you know how to read that. 2n minus 5. And that's the answer. Let's FOIL it out. 3n times 2n is 6n squared. 3n times negative 5 is negative 15n. Negative 1 times 2n is negative 2n. And negative 1 times negative 5 is positive 5. These two combine. Negative 15 minus 2 is negative 17n plus 5 right there. And then the 6n squared in front. So this is the original equation we started with, okay? See how fast that went? Once you get pretty good at these, it doesn't take forever to do these problems, okay? Okay, let's go on down here. Number 15 is something called a difference of squares. If you have a perfect square, a squared minus b squared, two perfect squares I should say, and they're subtracted, one minus the other, that's going to equal, I showed you this one a little earlier, it's going to equal a plus b times a minus b. Let's FOIL that out and prove it. A times a is a squared. I'm just proving this principle to you right now. A times negative b is negative ab. A times b, and there's positive, it's positive ab. And b times negative b is negative b squared. Positive ab minus ab cancels out. They go away. Okay, be sure you follow that. ab minus ab, the minus ab is first, but that doesn't matter. Positive ab minus ab is cancels. So you end up with just a squared minus b squared. Okay, so this principle is called the difference of squares. All right, so let's look at this. 4 is a perfect square, 2 times 2. X squared is a perfect square, x times x. And 25 is a perfect square, 5 times 5. So the trick here is to identify what is the a and what is the b. So I'm going to draw an empty parenthesis, put a square here. Then I'm going to draw a minus sign, and then I'm going to draw another empty parenthesis and put a square here. Okay. So think about it. What do you put in here so that when you square it, you get 4x squared? So remember, you're squaring two things here. You're squaring a number and you're squaring an x. So what do you put in here so that when you square each of those two things in here, you end up with 4x squared? What would that be? Well, to get 4, you would put a 2 in here. 2 squared equals 4. And to get an x squared, you would put an x in here. X squared equals x squared. So 2x squared equals 4x squared. Because you square the 2 to get the 4, and then you square the x to get the x squared. What about this one? This one's easier. What do you square to get 25? You square 5. 5 squared is 25. So the a, that's a sideways equal sign, just so you know what I'm writing there. That's the a, and this is the b. So what I have is a squared minus b squared. So the formula says that's going to be equal to a plus b times a minus b. So here's a, it's 2x, plus b, which is 5, times a, that's 2x again, minus b, so minus 5. And that's how you apply the difference of squares. Again, it just takes a second to FOIL it and see if it's true. 2x times 2x is 4x squared. X times x squared. 2x times negative 5 is negative 10x. And 5 times 2x is positive 10x. And 5 times negative 5 is negative 25. So these two group together. You have a plus 10x, a minus 10x, so they cancel each other out. So you end up with 4x squared minus 25. And that's your original equation up there, okay? But this is your answer. This is the factored form of that. Okay, that's how you do difference of squares. See how many of these they give you. I'll do one more for you, and then I'll give you an easier one to do. Okay, first of all, you got to find out, are these squares? Well, you got to kind of know what your squares are. 64 is a perfect square. It's 8 times 8. X squared is a perfect square. It's x times x. 49 is a perfect square. It's 7 times 7. And y is a perfect square. It's y times y. So what we're going to do is draw our open parentheses with the square minus open parentheses with the square. Okay, so what do we put in here to get 64x squared? So just take it one piece at a time. What do we square to get 64? And I just said it, it's 8. 8 squared is 64. What do I square to get x squared? And of course, that's an easy one, it's x. Okay, so 8x squared is going to equal 64x squared. Okay, same thing over here. What do I square to get 49? Well, I said that one as well, it's 7. And what do I square to get y squared? It's going to be y. So the a is what's in the parentheses, because it's a squared minus b squared. And this is the b, it's what's in these parentheses. Again, those are equal signs turned sideways, just so you know what I'm doing. Okay, so now we do our formula. It's a plus b, so it's 8x plus 7y times a minus b. 8x minus 7y. And that's your answer. Again, FOIL it out. 8x times 8x is 64x squared. 8x times negative 7y. Okay, that one's a little complicated. 8 times negative 7 is negative 56. And x times y, you can't anyway combine those. You just have to write xy. xy means x times y. Then over here I have 7 times 8 is positive 56. And x times y is xy. Okay, and then I have 7 times negative 7 is negative 49. Get rid of that thing. And y times y is y squared. Okay, so again, we combine the middle terms, and you have 56xy minus 56xy. That means that cancels out, and you end up with 64x squared minus 49y squared, and that's the same as your original equation up there. Okay, that's how you do those. So the last two were called difference of squares, and I'm going to leave this for you is 17, and it's also a difference of squares. Perfect square, and 1's a perfect square, right? 1 times 1 is 1, so that's a perfect square. And it's a negative sign, so it's a difference. Okay, so you're going to do that one. Okay, next is number 18, and let me zoom a little closer here. It's x to the third plus 64. So the first thing you have to recognize is that this is a perfect cube. It's x, and I'll put it in parentheses, to the third, plus another perfect cube. 64 is a perfect cube. It's 4 to the third. So I'm going to teach you a couple of new laws of polynomials here. You weren't expected to know these. You're not expected to figure them out. So I'm just going to teach them to you here. When you have, this is called the sum of cubes, okay? You're adding two perfect cubes together. And the way that works is this: a to the third plus b to the third equals a plus b times a squared minus ab plus b squared. Okay, again, you're not expected to have known that or to figure that out. That's part of the instruction. This is an instruction video as well as an answers video. Let me show you the other one, which you don't need for this problem, but you might need it later on. In fact, on the next problem you will, and that's called the difference of perfect cubes. It's a to the third minus b to the third. And that's going to equal, you change the sign here and change the sign there. So it's going to be a minus b times a squared, and then this becomes a plus sign, ab plus b squared. Okay, so this is the sum of perfect cubes, the difference of perfect cubes. So this is the one we need for this problem. So you've got to identify what your a and b are. Well, we already did that. The a is the x and the b is the 4. So now what you're going to go ahead is just fill in all these a's and b's with either an x or a 4 here. Okay, so let's go ahead and do that. So it's a plus b, so that's going to be x plus 4 times a squared, that's x squared, minus ab, so minus 4 times x. Again, minus ab. Minus a is the x, b is the 4, but you always write the number first, as you know. So it's minus 4x, minus ab. And then it's plus b squared, so that's plus 4 squared. And 4 squared, we all know, is 16, okay? I'll just write here just how we got that. 4 squared is going to be that. So it's b squared, b is 4, so it's b squared, so 4 squared is 16. Okay? And that is it. You cannot simplify that any further. You could not factor this, just take my word for that. So this is your final answer. Now, if you say, can you check your work by multiplying it? Yeah, you'd have to set up a grid because you have an x and a 4 here. You have an x squared, a minus 4x, 16. Set up a grid and do it, and you'll come out with it equaling basically x to the third plus 4 to the third, or plus 64. But I'm not going to do that here, okay? So anyway, just remember these two. You're going to use them later on. So in the next problem, you're going to use the difference here. Okay, so again, what we have to do is this. Open parenthesis to the third minus open parenthesis to the third. Okay, so what do we put in here to get 8x to the third? So take it one piece at a time. What do you cube, that is multiply by itself 3 times, to get 8? And I think most of you can see that's going to be 2. 2 times 2 times 2 is 8. That's 2 to the third power. Now what do you multiply, or what do you raise to the third power to get x to the third? And that one's kind of obvious, it's x. So 2x, all raised to the third, that's going to be the 8, and that's going to be the x to the third, so that's that. So that's going to be the a. Okay, now what do you raise to the third power to get 27? You kind of got to know your cubes. You just assume there's an easy answer to it, that there's not going to give you one that's impossible. Well, 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. 3 times 3 times 3, aha, you just do that on a calculator, that's 27. So it's going to be 3 cubed. So 3 is going to be the b. So 2x is a, and 3 is b. So I'd like you to write the formulas out every time so you get used to them. So a to the third minus b to the third equals, I'm just copying it from up here, but you want to eventually memorize it by just writing it out a lot of times. It's a minus b, it's a squared plus ab plus b squared. Okay, there you go. All right, now we plug in the numbers. A is 2x, so right there. So right below it, I'm going to just write it. 2x minus b is equal to 3, parenthesis. Then it's a squared, so that's 2x squared. So 2 squared is 4, and x squared is x squared. So that's the a squared. Remember, you're squaring both the 2 and the x there. Next is plus ab. So plus 2x times 3. And we can simplify that. We'll do that on the next step. And finally, last is b squared. That's 3 squared, so it's plus 3 squared. So we can just do a little more simplification here. It's 2x minus 3, 4x squared, plus 6x. 2 times 3. Now we're simplifying this. 2 times 3 is 6x, plus 3 squared is 9. And that's your final answer. Okay? All right, that's all there is to that. We're not going to, again, verify it. Take a lot of time to do that. Okay, next up. Couple more. Okay, so the only thing you're asking yourself now is, are these all perfect cubes? Well, 125 is 5 to the third. I'll write it up here. X to the third is x to the third. And 8 is 2 to the third. So these are all perfect cubes. So again, we're going to draw our open parentheses and put a cube there, plus open parentheses and put a cube there. So what do we have to cube to get 125? So again, just try out different numbers if you're not sure. 3 times 3 times 3 is 27. 4 times 4 times 4 is 64. 5 times 5 times 5 is 125. So it's got to be a 5. 5 to the third is 125. And then, of course, to get the x to the third, that's going to be an x. So that cubed is 125. That cubed is x to the third. What about this one? You should be able to do this one, right? That's going to be a 2. 2 to the third is 8. So the 5x equals the a, and the 2 equals the b. And this is the sum of cubes. So it's going to be a cubed plus b cubed equals a plus b. And then it's a squared, and then the only minus sign you have is right there, minus ab plus b squared. Okay? So a is 5x plus b is 2. Okay, a squared is 5x squared. So 5 squared is 25, and x squared is x squared. Okay, minus a, which is 5x, times b, which is 2, and then plus b squared, which is 2 squared. So I can simplify these terms right here, so I'll do that. 5x plus 2, 25x squared, minus 5 times x times 2 is 10. 5 times 2 is 10, x, and 2 squared is 4. And that's the answer to that. Okay, go ahead and get that written down and stop the video if you need to. Okay, here we go. Finally, number 22. F of x is just a way of saying y. It says a function of x, that x is your only variable. It's just a way of saying y equals something. It's just a different notation, but it doesn't mean anything special other than that. Okay, so we're going to factor this. So we can see, first of all, that an x, you see an x in all three terms, so you know an x will come out. You can see that you got prime numbers here, here, and here, so none of the numbers will factor out, but only the x will. So let's go ahead and do that. So I have an x to the third, x squared, and x. So again, x to the third is x times x times x. X squared is x times x, and x is x. So what they have in common is a single x, so you can pull a single x out of there. So I'm going to pull an x out, and then that leaves me with 2x squared plus, pulled an x out of there, 5x minus 3. So be sure you understand how I got that. Just go back and redistribute it. X times 2x squared is 2x to the third, that's this term. X times 5x is 5x squared, that's this term. And x times negative 3 is negative 3x, so that's that term. So an x factored out and left us with this. Now we're going to see if this factors, okay? So here we go. Grand product is 2 times negative 3. That's going to give you negative 6, so you have to multiply, find two numbers that multiply to negative 6. And they have to add to the number in the middle here, 5. Okay, if they multiply to a negative number, one of them has to be negative, one of them has to be positive. Since they add up to a positive number, the bigger of the two has to be the positive. So I'm going to start with a negative 1, positive 6. And that's going to equal negative 6. And negative 1 plus 6 equals 5. So right off the bat, we found the two numbers. It's negative 1 and 6. So now we're going to take the 2x only and make a ratio 2x over negative 1 and then 2x over 6. Okay, well you can't reduce this one any further, so that's simply going to be 2x minus 1. And this one reduces. 2 goes into 2 one time, and 2 goes into 6 3 times. So it's 1x over 3, or that's going to be x over 3. So that's going to be x plus 3. Again, the plus sign implied plus sign right there, so it's an x plus 3. Okay, so is that your final answer? No, don't forget this x here that we kind of set aside for the time. So you bring that down, and that goes out there. Okay, so that is the final answer for that one, okay? All right, so that's the entire assignment 2.02. It's a little bit long. It's almost an hour and 20 minutes. But remember, it's both an instruction video and an answers video, and I did every single problem. So the key for you is be sure you know how to do these problems, not just copy them, but you know how to actually do them, okay? All right, that's it, and we'll get the 2.03 video up. The 2.01 has already been posted, and we'll get 2.03 up very quickly, okay? And we'll see you in class next week.